on to our very last way to solve quadratic equations. Remember, so far we've done graphing, factoring, square roots, and completing the square. The quadratic formula is awesome because it seriously works every single time. It is very time-consuming, though, and because of that, there's tons of room for mistakes. But it's a good one to use because it works when factoring doesn't work, when you can't square root it, or just because you don't like to complete the square. Speaking of completing the square, since we know how to do that, we can use that method to discover what the quadratic formula actually is. If you already know what it is, awesome. But this is pretty cool that we can prove this gigantic formula together. So pretend we have this standard form of a quadratic, ax squared plus bx plus c, and it equals 0. Remember, it equals 0 because we want to find the zeros, or the solutions of the function, x's that when I plug in give me 0 for y out. First thing I notice is that we have a number in front of our x squared term. For the ones that we did for completing the square, we need to get rid of that number. So to get rid of this a, I'm going to divide everything by a. So the a's cross off, and I'm left with plain old x squared plus b over a times x plus c over a. And it equals 0 divided by a is just 0. So now what we need to do is get rid of our constant value, that's c divided by a, so that we can make a perfect square that can be factored. So let's move this c divided by a over to the other side. And now we're left with x squared plus b divided by a times x plus our mystery thing that we're going to find in a second, and that equals negative c divided by a. So now we need to complete the square. We know in our parentheses there's going to be an x here, and we're going to square something. And remember, we take b divided by a, or whatever this is, and we divide it by 2. So remember, dividing by 2 is just like multiplying by the reciprocal. So what we're really doing is b divided by a times 1/2, which gives us b on the top and 2a on the bottom. So that's what we have down here, plus b over 2a. Now remember, to get to this part that's up here, we need to take what we found, that b divided by 2a, and square it. So if we have b divided by 2a and we square it, remember we can distribute that square. So we get b squared on top divided by 2 squared, which is 4, times a squared. So that's what goes up here. I know this is pretty messy. And then we can't just go adding things to one side of the equation. Whatever we do to one side, we have to do to the other. So when I go to add these guys together to make my blue part here equal that, we can turn these into common denominators, just what we did in chapter 12. So the common denominator here would be 4a squared. So this one already has that, so we just have a b here. What is negative c over a missing? Well, we have to multiply by 4, and we have to multiply by another a. So we get negative 4ac. So add all that up. Oh, sorry, hold on. This should be b squared here, which means it should be b squared here, which means it should be b squared there. Sorry about that. So now we can add up what's on the top and leave the bottom alone. So we have negative 4ac plus b squared, all divided by 4a squared. So think back to how we completed the square. We have this perfect square that we can take the square root of on both sides. So on this side, we're left with x plus b over 2a. And that equals, remember when we take the square root of things, we can do the square root of what's on the top. So b squared minus 4ac. Flipping that around so it looks a little better. Divided by the square root of 4a squared. Now in the bottom, that 4a squared, that's something that we can take the square root of. We know the square root of 4. We know the square root of a squared. So let's rewrite that. This stuff's alone equals the square root of b squared minus 4ac. Square root of 4 will give us 2, and the square root of a squared gives us a. Almost done. We have to remember two things that we forgot here. We need a plus or a minus. And then also remember what we're doing here. We are trying to get x by itself. So x has plus b over 2a. So I need to subtract b over 2a from both sides. So now x is finally alone. And x equals, since these have the same denominator, we can combine them. Negative b plus or minus the square root of b squared minus 4ac, all divided by that same denominator, which is 2a. And there you go. There is the quadratic formula. I know it took a lot to get, but now you know this just isn't something we made up. You know where this came from. If you complete the square with these mystery values, you end up with negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And this was something that mathematicians actually did a long time ago, and now we can just give it to you in the textbook. So most of the time it is just given. You're told to plug and chug, and then that's it. I like to know where things came from. So pretty cool that we know where this gigantic formula came from. But now let's actually use this formula to solve for some x's. So problem number 1, I have 2x squared plus 3x minus 5, and it equals 0. It always needs to equal 0. So double check that first. This one does. And now let's write down our values that we're going to plug in. A equals 2, the number in front of x squared. B, the number in front of x, is 3. And C is our constant, which is negative 5. So now that we know that, I want you guys to write down the quadratic formula every single time. The more you write it down, the more it will stick in your head. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. And let's plug in our values. We have the opposite of b, so x equals a negative 3, plus or minus the square root of 3 squared minus 4 times 2 times negative 5, all divided by 2 times our a value, which is 2. And now it's simplifying. This is why this method takes a long time. There's lots of simplifying, and there's lots of room for mistakes. So let's be careful as we continue. I have negative 3 plus or minus. We got a bunch of stuff inside the square root. So 3 squared is going to give me 9. And then I have this mess right here. Negative 4 times 2 gives me negative 8. And if I multiply that by negative 5, I end up with 40. And then it's all divided by 2 times 2, or 4. So let's keep on going. We can simplify what's inside the square root. We get the square root of 49 divided by 4. And we know the square root of 49 is 7. So this is where we need to start breaking this up into 2 different problems, just like we did with the completing the square stuff. So my first problem could be negative 3 plus 7. Take that answer and divide by 4. The other answer could be negative 3 minus 7. Take that answer and divide by 4. So this very first one, if I add negative 3 to positive 7, I get 4. And 4 over 4 is 1. One possibility for x. Do the same thing here, I get negative 10 over 4. And a 2 can go into both of those, so we get negative 5 halves. There's another option for x. So our 2 solutions are 1 and negative 5 halves, or you could write negative 2.5. The math really isn't that difficult, there's just a lot of it. So let's do another one together. Let's do number 2. I'm going to put it on a different page so we have some more room, but the first thing that I notice is it doesn't equal 0. Always make it equal to 0. So since x squared and negative 3 are already on the right side, let's put 2x on the right side also. So I'm going to subtract 2x from both. And now I get 0 equals x squared minus 2x minus 3. And now we can pick out our values, our a, our b, and our c. A is 1, b is negative 2, and c is negative 3. So again, write down the quadratic formula. The more you write it down, the more it will stick in your head. X equals negative b plus or minus the square root b squared minus 4 times a times c. And this whole thing is divided by 2 times a. So now let's plug some stuff in. This right here says that I want to take the opposite of whatever my b value is. So I have like negative 2, or positive 2 when we simplify it, plus or minus negative 2 squared minus 4 times 1 times negative 3. And it's all divided by 2 times 1. So let's keep simplifying. We know that the opposite of negative 2 is just positive 2, so that's what we're going to have on the outside. Plus or minus the square root of negative 2 squared. Remember, if you type that in your calculator, you need to have those parentheses on it. It's negative 2 times negative 2, which gives us positive 4. And then again, I have this mess right here. Negative 4 times 1 times negative 3 will give me a positive 12. And then it's all divided by 2 times 1. That's pretty easy. Just 2. So one more simplifying process of all the stuff that's underneath the square root. We get a nice perfect square again. We all know the square root of 16. So now we're at the point where we can split this up into 2 different problems. One option is to have 2 plus 4 all divided by 2. And then the other one is 2 minus 4 all divided by 2. So solve these guys separately. 2 plus 4 is going to give me 6. 6 over 2 is just 3. So there's one solution that x equals. Remember, all of this is what x equals. And then if I do this one, I get negative 2 on the top divided by 2, which is negative 1. So another solution for x. And remember, you can always check these. Even though we did all of this work already, hope that you're correct or check it. So 3 can be plugged in here. We get 6 equals 3 squared, which is 9 minus 3. Yay, it works. And you can do the same thing with negative 1. This would be negative 2 equals 1 minus 3. And you get negative 2 again. Alright, the next ones that we have to do will not have perfect squares inside the square roots. Everything else is exactly the same. So just like the problems that we've done in the past, we estimate the solutions. I like to see 2 decimal places. So this is going to be the end of this video. Try and see that you can do this, and then watch part 2 with some story problems and a good wrap-up of all of the solving quadratics that we've done so far.